Welcome to the second session of this unit. So if A, B, and C are the three angles of a triangle, then the condition has been satisfied. The switch is in the on position, and we have to conclude that the sum of A, B, and C is 180 degrees. Let's look at the next one. As a person increases consumption of a product while keeping consumption of other products constant, there is a decline in the marginal utility that person derives from consuming each additional unit of that product. This can actually be written as, if a person consumes an additional unit of a product without consuming anything else, then the marginal utility that he derives from it will be less than the marginal utility he derived from consuming the previous unit. If you look at this restated reason carefully, there are actually two conditions. One, has a person consumed an additional unit of a product? Two, has that person consumed any other product? These two conditions need two different switches. Now, think back to the method that we learned in the last video. What do you think we should be doing when we come across two switches? Yes, if you remember the lessons from the last video, you will know that we should figure out the relationship between these two switches. Let's look again and find out the relationship. As a person increases consumption of a product while keeping consumption of other products constant, what is the clue here? The word while indicates that both conditions are required concurrently. That is, both conditions are necessary to arrive at the conclusion. Only if both switches are turned on can we reasonably conclude that the marginal utility derived from the additional unit is lesser than the marginal utility derived from consuming the previous unit. From our lessons in the previous unit, we know that these concurrent conditions are switches connected in a series. The first switch is on because Rachit has consumed a third biscuit after consuming a second one. The third one is the additional unit compared to the second. Secondly, Rachit has not consumed anything else, so both switches are turned on. Therefore, we have to conclude that the marginal utility that Rachit derived from the third biscuit is lower than the marginal utility he derived from the second biscuit. Let's look at the next one. The school assembly happens every Wednesday at 10 a.m. on the basketball court. If it rains, it is shifted indoors to the auditorium. This can be reduced to, if it rains, the assembly is shifted indoors to the auditorium. It is quite simple. If it rains is the switch. If it is on, then we have to conclude the assembly is shifted indoors. It is reasonable. If it is off, then we cannot arrive at that conclusion. Now, if we look at the second reason, we also know that on the first Wednesday of July, it rained heavily. The condition is therefore satisfied and the switch is on. We have to conclude that the assembly was shifted indoors on that day. Now we have to make another small mental shift. We will segregate our reasons into principles and facts. No need to get confused here. Their role still remains that of being the building blocks in an argument. It's just that we have identified two types of reasons. One is a principle, which is a reason in the abstract, that is, it applies generally, and the second is a fact. It refers to a specific instance. Making this shift is important to come to terms with the principle-fact model of the law entrance exams. If you go back in this video and look at all the previous examples that we have seen in this unit, you will realize that in all of them, one reason was a principle and the other was a fact or a set of facts. All men are mortal is the principle, Socrates is a man is a fact. With this, let us look at another example. Principle. If the visibility is less than 200 meters, only aircraft equipped with radio navigation systems will be allowed to land. Facts. Philip was traveling from Mumbai to Delhi on an aircraft that was not equipped with radio navigation systems. Visibility at less than 100 meters was very bad. Both of these are reasons, but one of them is a principle and the other is a fact. How do we take this forward? Let's look at the principle closely. What exactly is it saying? It is saying that for an aircraft to land in low visibility conditions, it needs to have the appropriate equipment. What is unsaid in this principle is that when visibility is not poor, an aircraft is allowed to land, no questions asked. So there are really two situations in which an aircraft is allowed to land. One, where the visibility is not less than 200 meters, then the aircraft is allowed to land, no questions asked. Two, where the visibility is lower than 200 meters and if the aircraft has a radio navigation system. We have noted here that these two situations cover the total number of situations. Situations where visibility is poor and situations where visibility is not poor. This is easier to visualize if you have two different circuits. If we visualize the first situation, all we need is a switch to see whether visibility is not less than 200 meters. If the answer is yes, we can conclude that the aircraft will be allowed to land. The second one needs two switches. The first looks at whether visibility is less than 200 meters, and the second looks at whether the aircraft is properly equipped. How are they related? The second switch only comes into the picture when the first one is on. That is, the question of radio navigation systems is only relevant when the visibility is less than 200 meters. This is important when we visualize this as a circuit, because the second one necessarily has to follow the first. The first switch will look at whether the visibility is less than 200 meters. If the answer is no, then we can conclude that the aircraft will be allowed to land. If the answer is yes, we then need the next switch to look at whether the aircraft has the necessary equipment. Only if the answer to that too is yes, can we conclude that the aircraft is allowed to land. Thus, we have two different circuits, but we need to remember that these two circuits take care of all possible scenarios. Visibility is either less than 200 meters or greater or equal to 200 meters. There is no third possibility. One circuit takes care of scenarios where visibility is less than 200 meters, and the other circuit looks at all the other scenarios. Now let's apply the facts to which of these switches need to be turned on. Visibility is at 100 meters. So, A, the lone switch in the first circuit is turned off, and B, the first switch in the second circuit is turned on. We cannot reasonably arrive at the conclusion in the first scenario. Philip's aircraft had no radio navigation systems, so the second switch in the second circuit is turned off, and we cannot reasonably arrive at the conclusion in the second scenario either. So in neither situation have we been able to conclude that the aircraft will be allowed to land. However, we know that these two situations cover all possible situations. Therefore, we can actually conclude that the aircraft will not be allowed to land. And with that, we have come to the end of the second session of this unit. Continue learning with the next video.